For years, the story of artificial intelligence has been a story of scale, of bigger, always being better. We imagined massive data centers, room sized supercomputers, and AI systems that consumed the energy of small cities just to think. But today, I want to tell you about a quiet revolution that's happening right under our noses, literally. A revolution that's about to put the power of advanced AI not in distant clouds, but right in your pocket. Welcome to the era of small, efficient models, where less is not just more, it's transformational. The conventional wisdom in AI has been simple: more parameters equal better performance. The biggest models, GPT-4, Claude, Gemini, contain hundreds of billions of parameters and require enormous computational resources. They're undeniably powerful, but they come with a cost. They need constant internet connections, massive server farms, and enormous energy consumption. But what if I told you that researchers have found ways to compress most of that intelligence into models small enough to run on your smartphone? That's exactly what's happening, and it's about to change everything. The breakthrough isn't just about making things smaller, it's about making them smarter in fundamentally different ways. Companies like Apple, Google, and a host of startups are developing AI models that can deliver impressive performance while using a fraction of the computational resources of their larger cousins. Consider what Apple achieved with their neural engine chips. These aren't just faster processors. They're specialized AI accelerators that can run sophisticated machine learning models directly on your device. Your iPhone can now perform real-time language translation, advanced photo analysis, and voice recognition without ever sending your data to the cloud. Or look at Google's work with MobileBert and DistillBert, models that retain most of the capabilities of their full-sized versions while being small enough to run on mobile devices. These aren't just scaled-down versions. They're architecturally optimized to be efficient while maintaining intelligence. But the real magic is happening in techniques like model compression, quantization, and knowledge distillation. These approaches allow researchers to take the knowledge from massive models and compress it into much smaller forms. It's like taking a library and condensing it into a single, incredibly dense book that somehow contains all the essential knowledge. Take Anthropic's work on constitutional AI or OpenAI's experiments with model distillation. They're finding ways to transfer the reasoning capabilities of large models into smaller ones, creating AI systems that can run locally while still providing sophisticated, nuanced responses. The implications are staggering. Imagine AI assistants that work perfectly even when you're offline, in areas with poor internet connectivity, or in situations where privacy is paramount. Imagine creative tools that can help you write, compose music, or create art without ever sending your ideas to a corporate server. This shift toward edge computing isn't just about convenience, it's about democratization. When AI can run locally, it becomes accessible to billions of people who don't have reliable high-speed internet connections. It becomes available in remote areas, in developing countries, and in situations where cloud-based AI simply isn't practical. But perhaps most importantly, local AI is private AI. When your data never leaves your device, you maintain complete control over your information. Your conversations, your documents, your creative work, all of it stays with you. This isn't just a technical advantage, it's a fundamental shift toward digital sovereignty. The medical implications alone are revolutionary. Imagine diagnostic AI that can run on a tablet in a rural clinic, providing sophisticated medical analysis without requiring an internet connection. Or consider mental health applications that can provide support and guidance while guaranteeing complete privacy. In education, small models could provide personalized tutoring that adapts to each student's learning style, all while running locally on school devices. No internet required, no data concerns, just intelligent, personalized education available everywhere. The creative possibilities are equally exciting. We're seeing the emergence of AI art tools, music composition software, and writing assistants that can run entirely on personal devices. This means creators can experiment, iterate, and produce without limits, without costs, and without compromising their creative privacy. But the technical challenges are immense. Compressing intelligence without losing capability requires breakthrough innovations in model architecture, training techniques, and hardware design. Researchers are exploring everything from sparse neural networks to neuromorphic computing chips that mimic the efficiency of biological brains. One of the most promising approaches is called mixture of experts. Models that activate only the parts of their intelligence relevant to a specific task. Instead of running the entire model for every query, these systems can dynamically route problems to specialized subnetworks, dramatically improving efficiency. There's also exciting work in federated learning, where small models can collaborate and learn from each other without sharing raw data. Imagine your phone's AI getting smarter by learning from patterns across millions of other devices, all while keeping your personal information completely private. The hardware revolution is equally important. Companies like ARM, Qualcomm, and Apple are designing chips specifically optimized for AI workloads. These aren't just faster processors. They're fundamentally different architectures that can perform AI computations with remarkable efficiency. We're even seeing the emergence of photonic computing and quantum-inspired architectures that could make local AI even more powerful and efficient. The boundary between what's possible in the cloud and what's possible on your device is rapidly dissolving. But this revolution also raises important questions. How do we ensure that smaller models maintain the safety and alignment properties of their larger counterparts? How do we prevent the democratization of AI from also democratizing potential misuse? There's also the challenge of keeping these local models updated and accurate. Large models benefit from constant retraining on fresh data. Local models need new approaches to stay current without compromising their core advantage of independence. Yet, despite these challenges, the trajectory is clear. We're moving toward a future where every device is intelligent, where AI assistance is always available, and where the power of artificial intelligence belongs to individuals, not just corporations. This isn't just about making AI more convenient or more private, though it certainly does both. This is about fundamentally changing the relationship between humans and artificial intelligence. Instead of AI being something that happens to us in distant servers, it becomes something that works with us, in our devices, under our control. The future of AI isn't just in the cloud anymore. It's distributed, democratized, and personal. The age of small, efficient models isn't just a technical evolution, it's a revolution in how we think about intelligence, privacy, and the relationship between humans and machines. We stand at the threshold of an era where artificial intelligence is not a remote service, but a personal capability, where the most powerful AI tools work for us, not despite our privacy concerns, but because of them. The cloud will always have its place, but it's now joined by a powerful personal countercurrent. Power is moving from the few to the many, from the cloud to the individual. We are at the dawn of a new computing paradigm, one that is more private, more accessible, and more deeply integrated into our lives than ever before. The future isn't just coming, we're holding it in our hands, and it's up to us to decide what we do with it.